Hi friends, we are the students of Vailtech Dr. RR and SR Technical University. This video showcases our final year project. The title of our project is Maximum Power Extraction from Hybrid Energy Sources Using Integrated Converter. And these are our batch members of the project and we belong to EEE department. As you can see, this is the hardware prototype of the project. The main idea of a project is to use renewable energy sources as a source for electricity, as renewable energy sources have zero fuel cost and less environmental factors. So this is the hardware prototype of the project, and as you can see, this is the circuit diagram of a project. This proposal focuses on control of two major renewable energy sources, photovoltaic and wind energy. So here, this is the point where we give two input sources. One we take it from wind, another we take it from solar. As this is just a prototype, we have just used a regulated power supply. Wind and solar power are given as the input to the converter. This is the converter section. In this proposed model, a hybrid system with multi-input integrated converter structure is proposed. This circuit consists of integrated CUC and SEPIC converters. The inherent nature of the proposed circuit is that it does not require additional input filters to filter out the frequency harmonics. The output from the converter is given to the inverter, which converts DC to AC and is applied to the load. The load used here is a resistive load. By using these converters, step up and step down operations can be done. The proposed converter is valuable for renewable energy harvesting applications. Now, let me explain you about the operation of a CUC converter. As you can see in the structural diagram, the converter connected to the solar panel is a CUC converter, and the converter connected to the windmill is a SEPIC converter. The operation of the CUC converter is it is a type of a DC to DC converter that has an output voltage magnitude that is either greater than or less than the input voltage magnitude. The CUC converter contains inductor in series with the converter input and output. The switch network alternatively connects a capacitor to the input and the output inductor. This is the switch, and the switch used in our project is a MOSFET. This converter also inverts the voltage polarity while either increasing or decreasing the voltage magnitude. Then comes the SEPIC converter. SEPIC converter is nothing but a single-ended primary inductor converter and is also a type of DC to DC converter, and it is connected to the windmill. It consists of two inductors and three capacitance and a diode. The output of the SEPIC converter is controlled by the duty cycle of this control switch. Now let me tell you about the integrated converter topology. The main focuses of using this integrated converter topology is to reduce the number of circuit components and also to increase the system efficiency. The feature of the proposed integrated topologies are the inherent nature of these two converters enables to step up and step down energy simultaneously. System works on the presence of both or any one of the renewable sources. Individual and simultaneous operation is supported. Now let me explain you about the hardware part. What we have done here is we have taken a 230 volt supply, used a step down transformers to step down the voltage to a 12 volt supply, and with the use of regulator we are giving it as an input to the converter in the place of windmill. So in the place of solar panel we have used a regulated power supply. So here what you can see is a regulated power regulator and a LC filter present in the chip board. This is used for giving a 5 volt supply to the optocouplers and driver circuit ICs. So these you can see are the optocoupler ICs, and these are the driver circuit ICs. And as I said earlier, the control switch which we are using in the circuit is our MOSFETs, and these are present over here. And this is the inverter section. What we use here is a full bridge inverter, so in which consists of 4 MOSFETs, and the driver circuits for this is given below. This project consists of two cases. Case 1, when only wind source is available. Take for instance, when only wind source is available, the switch 2 closes, the diode D1 turns off and diode D2 turns on. So this circuit becomes a SEPIC converter and the output is derived to the load. The case 2 is when only photovoltaic is available. In this case, D2 turns off and D1 turns on, and the circuit becomes a cup converter and the output is derived to the load. So by using these two cases, energy is delivered to the load irrespective of available of the sources, either single or multi-purpose. So these separate converters are integrated in order to minimize the circuit components and to improve the circuit efficiency. Thank you. Thank you.